In this video, I'm going to take a look at the side case and hopefully the side angle side case. So this first problem I've got, solve triangle, this triangle here, and I'm only given 3 pieces of information, and that's the 3 side lengths, little a, little b, little c. I don't know any of the angles. Okay, so I think I'll do my best to draw a triangle 3-ish, 5-ish, and 7-ish, something like this. If that's 3, then maybe that's 5, and this is the longest one, so maybe that's 7. So here's 7.2, that's little c. Little a is 3.1, and little b is about 5.4. So that makes this angle B, angle A, and angle C up top. All right, so I want to solve or find those 3 angles. Now I can't use the law of sines because I don't have a pair of information. I don't know any of the angles. So I think I'm going to have to bust out the law of cosines. With the law of cosines, if I know A, B, and C, then my only unknown would be that angle, and I could then solve for that angle. So I'm definitely going to be using the law of cosines. Now there is something to note here. When I don't know the angles, there's this possibility that I might have an obtuse angle, and those can be misleading, especially if we're using a calculator. So it's safe on the SSS case to always go after that obtuse angle first if it exists. Well, let's identify the case. I was given a side, and a side. So this is definitely the side scenario for that case. In that case, you go after the largest angle first. So, which angle was going to be the biggest? Well, A should be the shortest angle, B should be somewhere in the middle, and C should be the largest angle because it corresponds to the largest side length. So I'm going to use the law of cosines that deals with angle C. That's this bottom one here. So I have little c squared. So I'm going to have 7.2 squared. And that's equal to the other 2 side lengths summed and squared. A squared plus b squared minus twice those 2 values, so 2 times 3.1 times 5.4, times cosine of angle C. So side case, find the first or the largest angle first. So I'm going after angle C in this case, this situation. Now I have an equation with only one unknown. I should be able to solve for it. Decimals don't sound fun, so I'm going to get the calculator to help me out here. (7.2) squared, I get 51.84. Oops. I should know that value. (3.1) squared, I get 9.61. 5.4 squared, 29.16. I'll just do all this multiplication. 2 times 3.1 times 5.4. That cosine C has a coefficient of 33.48. I'm trying to solve for that cosine C, so I'm trying to isolate it. I'll add these 2 numbers together. They sum up to 43.09. I'm going to subtract that value from 51. I get 8.75. To get the cosine c by itself, I'm going to divide both sides by this coefficient, negative 33.48. And I get 0.26, I don't know where to round, but 14-ish is approximately equal to cosine of angle C. And that should be negative. Now that I've isolated the trig function, I can now solve for C. Now I can't do anything like multiplication or division anymore. This C is inside of a trig function. It's the input of a trig function. So what I'm going to do is introduce a different function, arc cosine or inverse cosine. That will take my inputs and outputs and interchange them. So the C is equal to an arc cosine or inverse cosine of negative 0.2614. All right, I'm going to throw this in the calculator, but before I do, let's think about that for a whole minute. Arc cosine. So when we talk about inverse cosine, we think about it from 0 to pi, so quadrants 1 and quadrants 2. And anything in the first quadrant, cosine better be a positive value. Those x values are positive. But as soon as I hit 90, cosine is 0. And anything bigger than 90, all of a sudden my x values become negative. So by putting in a negative 0.26, that's a really small negative number, I think we've got an obtuse angle sitting right here. This angle better be bigger than 90 degrees. I'm just going to hit inverse cosine on my calculator, negative 0.2614-ish. And then, yeah, I get the obtuse angle, 105, I'm going to round that up, 0.2 degrees. Perfect. So I found that first angle, 105.2 degrees. I'm going to go ahead and put that in my little box over here. And now I have an option. I could do this every single time. I could set up this law of cosines to find angle B, and then the law of cosines to find angle A. And that would work. That would give me the angles, just following this exact same procedure. Instead of just repeating myself, I think what I'll do is fall back on previous knowledge and use the law of sines to finish this problem. Because all of a sudden I have a pair of information. I know C and C, so I should be able to use the law of sines to put maybe B and B together. So this is the law of sines. I'm just kind of falling back on it. And it says if you have sine of angle C over little c, then it should be equal to sine of another angle like B over side length B. All right, I want to solve for B, so first I'll isolate sine of B. So I'm just going to simply multiply both sides of the equation by 5.4. Similarly to the C up above, the B is inside the argument of a trig function. So what I need to do here is introduce arc sine or inverse sine and take these two inputs and outputs and interchange them. So I'll have B is equal to arc sine of all that mess. I could probably reduce those there even, but I'm just going to leave it alone. And I'm just going to shove that into a calculator. And I'm looking for angle B. Little b was a smaller value, so it should be a value smaller than 105 degrees. And there's no other obtuse angle to worry about. A triangle can only have one obtuse angle. All right. Arc sine. I think I'll put a parentheses for my numerator. 5.4 sine 105.2. Close the sine, close the numerator, divide by 7.2, close the arc sine. I get B, the angle, is approximately 46.4-ish degrees. All right, I now have three options to find angle A. I could use the law of cosines. I could set up the law of sines once more, or I could just use the fact that these angles will add up to 180. I can't do mental math right now. So I'm just going to take 180 and subtract these two angles. And I get this little acute angle, 28.4. So we started off with 3 side lengths, no pairs of information. So we used the law of cosines. When we did the side case, we went after the largest angle first. All right, my next example is side angle side case. But I'm asked to solve a triangle, and they've given us an A value of 15, B 10, and angle C is 60 degrees. So assuming I don't know the case, I'm just given this bits of information. I'm going to draw the triangle as best I can. I think I'll start with that angle. 60 degrees should look like that. And so that's angle C. Now, side length A and B are the ones touching C, because side length C is opposite of it. So I'll call this longer one little a, and this shorter one little b. So we were given a side, and then an angle, and then a side. Or 2 sides and their included angle. That angle is between those 2 sides. So this case, or this scenario that we're in, is the side angle side case. Written both frontwards and backwards the same. SAS. I do not know angle B. I do not know angle A. And I don't know little c. The law of sines will not work here because I do not know a pair of information. And I can't use, I can't find anything else. So I think I'm going to use the law of cosines, and I was given this angle C, so I think I'm going to use this bottom one again. I was given angle C. I know little a and little b, so then I should be able to solve for little c. So I'm going to use this version of the law of sines. Law of cosines. It says, little c squared is equal to the other side lengths summed and squared minus twice their product times cosine c. Oh wait, I know c. That's a 60 degrees. So for the side angle side case, we're going to use the law of cosines. We were given angle C, so I'm using the C version of the law of cosines. And the visitors' values, I can multiply real quick. 15 squared, is that 225? Yeah. 100. I think I can do this. 30 times 10 is 300. Oh, cosine 60, that's pretty. That is pi thirds, so that should be 1/2 sitting right there. I happen to know 60 degrees. If you don't, that's fine. You can just shove it into a calculator. Like if I give you 59 degrees, you'd have to use a calculator to get a decimal approximation, maybe. But I happen to know sine of 60 degrees is 1/2, so I can continue just to simplify this. 1/2 of 300 is 150. That should be 175. I'm just going to 325 minus 150. Yeah. Oh, this is easy. To solve for C, I can just square root both sides. If you're wanting a decimal approximation, you could plug it into the calculator. I happen to know that that simplifies. 175 has a factor of a perfect 25. 25 goes in 175 7 times. But if you want a decimal approximation, the square root of 175 is about 13.2. So I'm going to do some organization here. C was 60 and little c is about 13.2. B, I don't know yet, but little b is 10. A, I don't know yet, but little a is 15. All right. I now have a pair of information, so I think I'm ready to fall back on the law of sines. Yeah. But with that C value, I now have all 3 side lengths, so I could use the law of cosines to calculate the angles. So I've got options. I could calculate angle A or B using the law of cosines. I could fall back on the law of sines. And when I fall back on the law of sines, there is this worry about obtuse angles. For the side case, we went off after the obtuse angle first. Let's see. Oh, never mind. Oh, yeah. A is a little worrisome to me. So if there's an obtuse angle, it's going to be that A. And in order to find A, I'll have to inverse sine. And that has issues with obtuse angles. We can deal with it, but I think what I'd like to do is if I use the law of cosines first, and I fall back on the law of sines, I want to go after the shorter angle first. All right, so I just found that side length C. I have a pair of information. I'm going to pair up the C's with the B's because B is the shorter side length, so it'll have the shorter angle. So sine of angle C over little c is equal to sine of angle B over little b. I'm going to solve for sine b. I'm going to multiply both sides by 10. I think I know sine 60, but I'm just going to pretend I don't for a second. To get the b outside of the trig, function, I'm going to inverse sine that. So b is equal to arc sine or inverse sine of 10 times sine 60 over 13.2. Sine of 60 is root 3 over 2. So I could simplify, but I'm going to have to use a calculator anyway, so I'll just leave it as such. I'm going to get a decimal approximation. Let me, actually, before I do the arc sine, let me simplify what's inside, because I want to talk about that input. So I'm first going to take care of what's inside the parentheses. I'm going to take 10 sine 60 and divide by 13.2. And I get 0.6561-ish. So this is saying what angle will map sine to 0.65. So on a unit circle, there's actually two angles that will do that. For it to be a positive 0.6, it's got to be somewhere around here. But it could also be in quadrant 2. So this little angle maps to 0.6, as does this bigger angle. It also maps to 0.6. That y value on the unit circle is 0.6. So there's two possible angles. There's one in quadrant 1 and there's one in quadrant 2. So by me putting in a 0.6 into the calculator, it's going to always give me that shorter of the two answers. That's why I'm stressing over finding the shorter one first. Because by finding the shortest one first, I'm guaranteed, like I know it's going to be an acute angle. In a triangle, there can only be one obtuse angle. So by going after the smaller one first, I know it's an acute angle. So I know when I plug this in, I'm going to get an acute angle. Let's see if I can do this. That's in my calculator, so I can do second sine, second answer, and I get 41 degrees, basically. And I know it's 41. Okay, cool. 41 degrees. Go back up to my little triangle here. All I lack now is to find A. Law of cosines for sure will work. Law of sines has a little bit of iffiness to it. Or I can just subtract these two from 180. That's a 101, so that should be fine. How do I do this? There. All right, side, angle, side. Use the law of cosines to find one of the angles. You'll then have a pair of information. Go after the shorter angle first, and you'll be fine. I hope that helps.